Good morning, everyone. Today, I'm going to present my paper entitled Ensemble Learning Best Pork Freshness Classification with a Batteryless Sensor Tech. So, this is the content of my presentation for today. First, I'm going to introduce the concept of energy harvesting. Then I'm going to talk about our proposed system. Then our proposed taking ensemble learning, result in discussions and conclusion and future work. So let's talk a little bit about the energy harvesting. What is energy harvesting? Actually, energy harvesting means we collect radio frequency wave from space and convert them into electrical energy. Actually, there are two sources of RF energy, which are dedicated RF source and ambient RF source. In this research, we focus on the dedicated RF source. Why we employ energy harvesting for food monitoring technology? Because this technology can provide long-term operation. We do not need battery, and it is one of the cheap technology to employ. Even though there are some benefits employing energy harvesting, still there are challenges that we need to solve, which is energy harvesting technology has low power conversion efficiency. So what we do to solve this issue, we have to optimize each block of energy harvesting technology. For example, we have to design very optimized version of receiving antenna. And we also need to optimize the application itself. Okay, let's talk about the application of energy harvesting in food monitoring technology. According to WHO statistics, around 10% people get sick after eating contaminated food. So the food safety and freshness monitoring is very critical to develop. As you can see here in the pie chart, the foodborne illnesses mainly caused from bacteria. So in this case, our objective is to develop a battery-free meat freshness classification with high accuracy freshness detection, which is non-invasive and sustainable system. So this is the food monitoring technology and its disadvantages. Some methods use traditional one, which is assess the meat quality using texture, appearance, color, and smell. But this method is subjective. Sometimes it is inconsistent with the freshness state. Some more advanced technology is electric nose, but this technology is bulky and complex. We need frequent maintenance, and it is powered by cables. Sometimes this electric nose can damage the quality of the meat itself. Then this is the current energy harvesting and low power sensor based technology. Some of them based on pressure sensor, color sensor, gas sensor, and pH sensor. All of this has these advantages, but the most reliable gas is gas. The reliable sensor is gas, but there is issue in gas sensor. They consume high power. So what we are doing to tackle this issue, we optimize the energy harvesting technology itself. So this is our proposed system. First, dedicated RF source will emit radio wave in the 915 megahertz frequency. Then using 3D quasi-Yagi antenna, we receive this RF energy. Then using matching network, rectifier, and boost converter, we convert this RF signal to DC and store in a supercapacitor. Then this energy will be used to support to power our system based on gas sensor. Then we develop a machine learning model to classify the mid-freshness states and then send the data to the reader. The reader can be a PC or a smartphone. So this is the configuration for matching network. We choose pi matching network with the Dixon topology. Then in the gas sensor, we use CCS 811, and for the microcontroller, we use STM32 because this microcontroller consumes low power, and sensor text will transmit data to a reader device via Bluetooth. Let's move to the next section. Why we choose stacking ensemble learning? Because in the current machine learning model in classify the mid-freshness, it has limited accuracy. Then single machine learning model, it has restricted generalization, which means that for one particular food, the machine learning model will be different. So the solution is stacking ensemble learning. So this is how we collect data of pork for our machine learning model. We collected this data every 5 minutes over 5 days. Because there is no labeling standard in this case, so we refer to our previous published paper in IEEE Sensors Journal. So this is our proposed architecture of stacking ensemble learning. For the input feature, we use carbon dioxide, TVOC, and temperature. Then before training the first learners, we normalize the data set. And for the first learners, we are using MLP, GRU, LSTM, BLSTM, and 1D CNN. And for the meta learner, we choose 1D CNN. And for the classification itself, we categorize the mid-freshness into 3 categories, which are fresh, semi-fresh, and rotten. So this is the result and discussion. Based on the result by primary learners, you can see here 1D CNN achieved the highest accuracy of 93.051 accuracy. So our systems, stacking ensemble learning, will be automatically choose 1D CNN as the meta model. So this is the result for each confusion matrix for each first model. In terms of accuracy, as I already mentioned, 1D CNN achieved the best accuracy, so 1D CNN will be chosen as meta model. So we train meta model 1D CNN using this parameter after grid search CV. And this is the accuracy and loss of the training of 1D CNN. And this is the result of our meta model 1D CNN. As you can see here, the accuracy increased to 96.944%. So in this case, we conclude that ensemble learning will increase the accuracy of our mid-freshness classification technology. So this is the measurement of the pork freshness. As you can see here, the carbon dioxide level from day 1 to day 5 rise from 0 to 8,000 ppm. TVOC increases from 0 to 1,200 ppb. And we maintain the temperature between 20 degrees Celsius and 21 degrees Celsius. So this is the conclusions of our study. In terms of accuracy, 1D CNN achieved the best accuracy among those 5 machine learning models. We chose 1D CNN as the meta model because this model will combine the strengths of each first learners. And ensemble learning is very effective for different type of mid-freshness detection. And ensemble learning increases the accuracy. So for the future work, we are going to extend the system to classify other food types, for example, beef, fish, chicken. And we are going to explore additional models for the meta learner to improve the accuracy of our system. Okay, that's all my presentation. Thank you very much for listening. If you have any questions, please feel free to ask.